So today we're going to talk about theoretical and experimental probability. Probability is the measure of how likely an event is to occur. Each possible result of a probability experiment or situation is an outcome. The sample space is a set of all possible outcomes, and an event is an outcome or set of outcomes. So, for instance, the experiment might be rolling a number cube. Sample space would be the numbers 1, 2, 3, 4, 5, and 6. Okay? One outcome might be 4. Another outcome might be 5. Okay? Or an experiment could be spinning a spinner, and you could get red, blue, green, or yellow. Okay? Probabilities are written as fractions or decimals. From 0 to 1. Okay? Or you can write them as percents from 0 to 100%. Most of the time, fractions are fine, okay, unless they tell you otherwise. All right? If they say to write it as a percent, write it as a percent. If they say to write it as a decimal, write it as a decimal. But if they don't give you an option, then a fraction is fine. Okay? If you're using decimals, write your answer as a decimal. But if they are, normally you're just going to use fractions. Okay? Equally likely outcomes have the same chance of occurring. When you toss a fair coin, heads and tails are equally likely. Favorable outcomes are outcomes in a specified event. For equally likely outcomes, the theoretical probability of an event is the ratio of number of favorable outcomes to the total number of outcomes. And we're actually going to use this formula a lot today then in what we're doing. Okay? So the probability that an event occurs is going to be the number of favorable outcomes divided by the number of outcomes in this sample space. So, and I will be abbreviating it. Basically, I'll have favorable outcomes over total outcomes is the way I'll write it. So here we have the word probable is written on a separate card, or each letter is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? Okay. So we have our favorable outcomes divided by our total outcomes. So in this case, if I say it's a favorable outcome, what am I talking about? What specifically thing in this problem would be a favorable outcome? A consonant, okay? So we're looking for a consonant. I spelled that wrong, didn't I? That's pretty bad when it's written right there. There we go. Okay, which is sometimes I wonder about you guys because you do that. Okay, the word's written on the paper and you spell it wrong. Okay, all right, and what would be in the denominator then? What represents the total outcomes? Okay, the letters of probable. Okay, all right. So how many consonants are there? 5, right? Okay, P, R, B, B, and L. So there's 5 consonants. And how many letters are there in the word probable? 8. So the answer would be 5/8. Okay, 5 of the 8 cards have a consonant. All right, so the answer would be 5/8. Now, the reason that I'm getting that technical as far as the writing it down is so that when we get to the harder ones, we'll understand that. Okay? All right? Okay? Here we have two number cubes that are rolled. Now, this chart here is on page, let's see, yep, 803, and we'll be using it quite a few times. So you're actually going to want to mark that page right at the moment. So if you, hey, what did I just give you? A note card. Maybe that might be a good spot for your note card right now, because we're going to be coming back to this a lot in what we're doing in today and probably tomorrow. Okay? So it says, what is the probability that the difference between the two numbers is 4? Okay. So we have our favorable outcomes in the numerator and our total outcomes in the denominator. All right. So let's focus on the total first. How many total outcomes are there? There's 36 of them, right? Okay. I have 6 down and 6 across, which is 36. Okay. And how many of them then have a difference between them of 4? Well, let's see. We have a difference of 4 would be like 1 and 5, right? 6 and 2, and 1 and 5 here, and 6 and 2 there, right? Okay. So there are 4 of them that have a difference between the two numbers is 4. And so I would reduce my fraction, and 4 over 36 is 1/9. So that would be my answer, 1/9. All right, so we're doing favorable outcomes in the numerator, total outcomes in the denominator. It's usually easier to figure the total outcomes and then figure the number of favorable ones. Okay. All right, so try that with the complement of a probability is basically the opposite, okay? Or it's 1 minus the probability the event's going to happen. Right? So if I said, how many boys are there in the room? Then I could do 1 minus the probability that somebody is a girl, okay? And usually it's not something you use a lot, that formula isn't, but you can use it. So here we have 25 students in study hall. Don't you wish you had that? The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? Okay. So if we use the complement here, that means we would find the probability of the number of students who are, and then subtract that. So we have 18 and 3 is 21. So we would do 1 minus the probability of foreign language. That L looks like a parenthesis. Okay. I need one there anyway. Okay. So it'll be 1 minus the probability they are doing a foreign language. So 1 minus 21 out of 25, which is what? Okay, 4 out of 25. Okay. There we go. Okay. So a complement just means the opposite. So you could just figure that out, that, okay, there's 21 people doing a foreign language, so there must be 4 people left, right? And 4 out of 25 would be my answer. All right. Now here's the hardest part, well, in my mind, the hardest part about this one, is finding probability with permutations or combinations. Here, if each student receives a 5-digit locker combination, what is the probability of receiving a combination with all odd digits? Okay. Now, I'm going to go ahead and use what they have written down in this case. And some aspects I like it, some I don't, but I'm going to go ahead and use it. So first of all, the first thing we have to think about is that, is this a permutation or a combination for the code? Okay, does order matter?
No. Wait.
It's a locker combination, right? If I give you a locker combination of 2, 5, 7, 8, 9, isn't there a specific order to those? Yes, okay. So this is a permutation because order matters. Now, along with permutations then, okay, so order is important, so it's permutation. Now, we need to think about what are the total possible outcomes there are. Okay, it's a 5-digit locker combination, right? Okay, what did we do yesterday when we were talking about like a locker combination? What did I write down? I put down the dashes, right? So in this case, how many dashes am I going to have? 5, okay? And how many possibilities are there for each number in the combination? Now, this isn't a spin locker, okay? If it says a 5-digit locker combination, it's kind of like a bike lock, okay, where there would be 5 little dials on there. Okay, there's 10, right? You have 0 through 9, okay? So we have 5 different numbers that there are 10 choices for each of those numbers, right? Okay. So there are 10 to the 5th power, or 100,000 different possible outcomes. Yes? 0 would be an even number. Okay? Yeah. Okay? So the number of outcomes in the sample space are 100,000 total outcomes, all right? So if we were writing our fraction, we would put that in the denominator, okay? Okay, well, it says we want them all to be odd. So we need to look at our favorable outcomes now, okay? All right, so now we need to find the favorable ones. Well, how many odd digits are there? There's 5, right? So that means that I'm going to have another 5 dashes, okay? And each of those 5 dashes is going to be a 5. Right, so that means there are 3,125 favorable outcomes. Okay? Now, does that make sense? Okay. Okay. In the denominator, then, we're going to have our total outcomes, which there's 100,000 of them. That's the number of possible locker combinations there could be. Okay. In the numerator, then, we're going to have the favorable outcomes, which is the possible odd ones. And so my answer here is going to be 3,125, my favorable outcomes, over 100,000, my total possible outcomes, which reduces to 1 over 32. So this is a little bit tougher because it involves a little more thinking, okay? Because now there's more to the numerator and the denominator in this case than just, one possibility. So let's go through check it out together. Or let me do this. Let me give you a minute to. Okay, anybody think they have an answer? Okay, all right, what's the total? It's not 56. Okay, I know why you got 56 though. Okay, now, favorable over total. Okay, number of outcomes. Now, is this a permutation or combination? Okay, it's a combination, right? Because there's no order involved. It doesn't say I'm going to play this ad and then this ad. It just says I'm choosing 2 ads. Okay, so that means that my denominator is going to be a combination of 8, choose 2. Okay, that's the total possible outcomes. All right, now.
Why would you play the same ad twice in a row?
They're not playing the same ad. Okay, on a combination, you can't, combinations and permutations, they don't repeat. Okay, when I use the formulas, if I said a permutation of 8, choose 2, or a combination of 8, choose 2, these means nothing repeats itself. Okay, in the previous example, I have the numbers can repeat themselves on a locker combination, right? Okay, but here they're going to play two adds, and those two adds are going to be totally different adds. Okay, all right. So we have to figure out this number here, okay, first of all. All right, but then we have to look at our favorable outcomes. How many favorable outcomes are there? Now remember, it has to be less than whatever this number is, doesn't it? Because otherwise it wouldn't be a probability. Okay, it has to be less than 1. Okay, all right, and the number of favorable outcomes is 1. Okay, all right. She's selecting 2 ads, right? The DJ is selecting 2 ads. And 2 of the ads are by a local retailer. Okay? So the 2 ads that she selects, and there's only one way that those 2 ads can be by the local retailer. Right, because they don't repeat them. Okay? So if the local retailer has ad A and ad B, okay, there's only one way I can choose those 2 as my 2 ads, isn't it? Okay, because there's no order to them. All right. So if I choose their ads, there's only one way that can happen.
But if there was order, you could play B and A.
Right. If there was order, then there could. Yep. And then we'd have a permutation in the denominator also. So this is equal to 1 over, and what is 8 choose 2 combination? I think that's 28, isn't it? Okay. So the answer would be 1 over 28. Okay, another favorite is geometric probability. And with geometric probability, you actually have to use some of your geometry skills or area skills is basically what we're going to be working with. Okay? So here a figure is created placing a rectangle inside a triangle inside a square as shown. If a point inside the figure is chosen at random, what is the probability that the point is inside the shaded region? So what we need to do is we need to find the area of the whole thing. Okay, that would be our, but what part of our formula would that be? Okay, that would be the total, okay? And then the area, the shaded area would be our favorable part, okay? So we have favorable again over the total. And so the favorable is the shaded area. And the total would be the square, right? The whole figure. Right. So the denominator we have 9 times 9, right? 81. The area of the whole figure. Okay. Now how do we find the area of the shaded region? Okay. We have a triangle that's missing a rectangle, right? So how do we find the area of a triangle? Okay, 1/2 base times height. All right, so we've got 1/2 times 9 times 9, right? It's 9 across and 9 up. Okay. Minus 4 times 3, the area of the rectangle. All right, what's 9 times 9? 81, and half of that is 40.5, okay? So we have 40.5 minus 12, which is 28.5 over 81. Now, can I leave it like that? Can't, can you? All right, because I can't have a decimal in a fraction. How would I change this to so that it's just a fraction? What could I do? How many of you have a calculator in front of you? Okay. Take your calculator and type in 28.5 divided by 81. Okay, now change your answer to a fraction. Okay, what, Melissa? 19 over 54. Okay. So you can just take your calculator, and if you end up with a decimal in your fraction, right, 28.5 divided by 81, and then just change it back to a fraction. All right, get 19 over 54. Yes. How would you do it if you didn't have a calculator? You would double, okay? Because if I multiplied the whole thing by 2, okay, and then I would simplify the fraction. Okay. Yep. So you can do it. Okay. Experimental probability. Okay. Experimental probability means that somebody actually has conducted an experiment. Here are the results. Find the probability. Now, we started out talking about theoretical probability, where theoretical probability is, okay, if somebody flips a coin 50 times, what do we expect is going to happen? How many times? 25 heads, 25 tails, okay? But if you actually did it, you're probably not going to get 25 and 25, are you? Okay? If you did enough times, maybe, okay? Because eventually you are going to get there. Okay? But a theoretical probability says this is what's going to happen. If I have a spinner with 4 colors on it, okay, equally likely, then I would expect if I spun the spinner or spin the spinner, whatever you call it, if I spun it 100 times, I would expect to get 25 of each one. Okay? But if I actually did it, I might not get that. Okay? And so with experimental probability, we're going to look at the fact that it actually happened and what are the probabilities from that. So here's a table, and it shows the results of a spinner experiment. Find the probability of each. So the probability of spinning a 4. Well, first of all, we have to figure out how many times they spun it, right? Okay. All right. So we got to use our brain here to do fast adding. All right. I'm going to do fast adding right there. All right. Why do those combinations help me? Right, because they add the zeros, right? Okay. So we have 11 and 19 is 30, 6 and 14 is 20, so we have 50 chances. All right. So what's the probability that they spun a 4? Okay, so spinning a 4 would be 14 out of 50 or 7 out of 25. Make sure you always reduce your fractions. Letter B says spinning a number greater than 2. So that means I'm counting the 3s and the 4s. And so that would be 19 and 14 is, so this is 33 out of 50. Okay. We have 19 3s and 14 4s. I add them together. Right. So the biggest issue that we have sometimes when it says spinning a number greater than 2, sometimes people will use the 2s. Okay? If it says greater than 2, make sure you don't use the 2. Okay? All right?